Hello and welcome. So before I start actually using my state machines that we implemented in a couple of videos ago, before we actually start using our state machines, the first thing we want to do is uh, develop some sort of way to parse the commands that that the oscilloscope's going to respond to. So these would be the commands that we decided we're going to go with. So the waveform commands. So if I choose the small protocol, then I'm going to have to enter the WAV, the capital letter version of this command. So WAVSOUR. Otherwise, if I choose the long protocol, I'm going to have to type the whole command. So basically, we need to we need some sort of way to pass these commands, and we could just go with simple string parsing for this, but I'm actually going to use regular expressions because I want to cover that in this video series, as regular expressions are it's like a really powerful tool, and it's one of the really, I would recommend people to actually go ahead and learn regular expressions if they're trying to get into more Python-based stuff, especially data analysis and stuff like that. It's a really powerful tool, and I just want to cover that in this series. So without further ado, I want to get into it. So the first thing I want to do is get rid of this. So since we have implemented a header-based system, I don't want to be receiving messages randomly with a random buffer size. So obviously we need to implement a better way of receiving messages, and it will make sense for us to, at this point, create a function that would receive the messages. So I'm going to do just that. Create a function called receive message, and I'm going to receive the client socket object as the parameter. So So the next thing I'm going to do is try to receive data in here. So I'm going to say message header equals client socket dot actually I want to make sure that I'm not using this client socket up here, but the parameter passed in here. So I'm going to change it to that socket and receive header size. The next thing I want to do is check if not len message header. So if you don't receive anything, I'm going to say return false. And then the message length is going to be we're going to intify the whole thing. So intify message header dot decode, because it's going to be encoded. UTF-8. Yeah, and we also need to have some sort of accept. Before we do that, we're just gonna I'm just gonna put that first. Accept return false, and in here we're gonna return something else if we do get a message back. So I'm actually gonna return a dictionary here. So I'm gonna say the header is going to be message header, and I'm going to have another dictionary element in here, which is going to be data, and that's going to be client socket dot receive message length. And we're not going to decode it right here. We can decode it afterwards when we actually pull the data out. So that's going to be our receive message function. So now down here, instead of doing this, we can just do receive message, and in here we can now actually pass in the client socket, which is the client socket that we have here. Okay, so now this is going to be so this message is now going to hold a dictionary instead of a string. So what we need to make sure is when we're actually using the message here, I'm going to pull out the value stored in the data key in the message dictionary, and for some reason it's not liking it, and that is because we have double quotes in here, so inside it's going to have to be single quotes. Okay, so that seems fine. So the next thing I'm going to do is create another function, and I'm going to call it commands. And this is going to take one single parameter, which I'm going to call CMD for command, And in here, the first thing we need to do is check for the protocol that's selected. So if protocol dot upper equals L, then we're going to say response is equal to parse long, and this parse long is going to be passed in the CMD parameter that was passed into the command function itself. And if it's not the long protocol, so it must be the short protocol, so I'm just going to say else response is going to be parse short, and this is going to take CMD as well. And what we're going to do is then return the response. And this parse long and parse short are functions that we're going to create for passing two different protocols, and the protocol itself is the global variable that's going to store the protocol of the client that's currently connected to the server, as we can see here. So every time we connect to a new client, the protocol is going to be assigned the protocol of that client. Okay, so the next thing I'm going to do is actually create these two functions. And I want to keep this server.py file clean, so what I'm going to do is create another Python file in the main folder, and I'm going to call it cmd parser. And in here we're going to create the two functions, so I'm going to say def parse long, pass, and def parse short pass. And obviously it's going to take in the parameter cmd and cmd. Okay. And because I'm actually doing this in a different file, what I'm going to do is I am going to go back into server and pass the protocol into these two variables as well. Actually no, because we've actually we've done the if statement here. So if the protocol is long, only then are we going to go into this line. So we don't really need to pass the protocol into this. So our parser functions don't really need to be aware of the protocol. Well, in a sense they are aware, because we're only going to get to this if the protocol is long. Okay, so what I'm now going to do is import regular expressions, which is part of Python standard library, so you don't need to install it or anything. I'm going to say import RE, and that stands for regular expressions. And before we actually get into creating the patterns for the regular expression, what I'm going to do is take a look at the structure of these commands once again. So over here for the commands, we have a colon, and then we have the command thing, and we have another colon, and that's going to be the parameter of the command or something. And we come down here, so the command, the property actually, and that's going to be the parameter. We can see it as that. Okay, so and the query is going to be the command, the property with a question mark. So it's clear that most of these commands are going to be in this pattern, so we can use this pattern to then create a regular expression pattern. So what I'm going to do for that is, so for commands I'm going to say waveform cmd, and I'm going to say that's equal to re.compile. So this is going to compile the pattern that we want. And since I've only chosen to do the waveform command in here, so I've only chosen to go with these commands and not other commands, so I can be a bit more specific, but you can broaden your spectrum if you're going for more commands. So for the first one I'm just going to say waveform, and because I'm going to ignore the case later on, so I don't care about the case, so I'm going to emphasize that by making it a bit non-uniform. And obviously we need a colon here and colon there, and over here I'm going to say include any Unicode word that might come. So for that I'm going to do /w. So if I go into the documentation, you can see /w stands for Unicode string patterns. So it can be anything that has A to Z from either small or capital letters, and 0 to 9 numbers, and underscore. So I'm going to go back in here, and what I'm going to say is a plus, so it plus basically means it doesn't have to be a single Unicode character, but it could be like a chain of Unicode characters. And then what I'm going to do is add a space here. So if you go back into this pattern, you can see this colon, waveform, the property, and then there's a space before we actually add in the parameter. So that's why I have to add a space here, and I'm going to do the /w again because we need more Unicode characters, and I'm going to do the plus again. And lastly, I'm going to put a comma here and say re.ignore case, so we don't really care about the casing of this whole thing. So you can type it in as is, and I wouldn't care because we have chosen to ignore the case. Okay. Actually, I'm just going to get rid of this pass because we no longer need it. So the next thing I'm going to check for is if the command that was passed into this matches this pattern. So for that, I'm going to say if waveform cmd dot match. If it matches the CMD that was passed in, then what we're going to do is the first thing I'm going to do is just print out the whole thing. So print CMD is the command, and next thing I want to do is split up these two. So I'm going to split up the waveform and the type from the parameter. So what I'm going to do for that is I'm going to say command, comma, parameter. So this is, and the next thing I'm going to do is split the CMD. So CMD dot split, and I'm going to say none, comma 1. And this is going to split the whole thing based on the white space. So basically, it's going to split the waveform and the type from the parameter, and we're going to store that in com and parameters separately. Now, next thing I want to do is actually split up the command and its type. So, and because we know the first thing is always going to be waveform because we're only dealing with waveform commands, so all we are interested in is the type. So I'm going to say type is equal to cmd, actually no, com dot split based on the colons. So this is going to split this thing based on colons, and so it's going to have this bit here, which is going to be the first bit, and then it's going to have the waveform, which is going to be the second bit, and then it's going to have the type, which is going to be the third bit. And because we're dealing with arrays, the first bit's going to be 0, so the third bit's going to be the second one. So we're going to say we want the number, the one on number 2, so which is going to be the third one. Okay, so now that we have the command, the parameter, and the type separated, the next thing we're going to do, so now we're actually going to check for our most basic commands, which is, if we go back into this, which is source, mode, and format. So I'm going to say if type is equal to source. Actually, I'm going to say type dot upper is equal to source. Then we're going to do something. Elif type dot upper is equal to mode. Then we're going to do something else. Elif type dot upper is equal to format, and then we're going to do something else. Then I'm going to come out of this, and I'm going to say else print cmd command not found. Make sure you're okay. I'm gonna have to make a double quotes. Make sure you're sticking to the protocol. Okay, make that double quotes. Okay, and it's going to be pretty much the same for this, for a pass for now. So I'm going to copy that, and actually I'm going to copy the whole thing. and I am going to paste that here. And waveform, actually that should be waveform. That should be waveform. Let's make sure we. Okay, we're not using that there. Waveform. And in here it's just gonna be wave. So we make sure it's just that. And for source is gonna be sour. And mode is gonna stay mode. Format I think is just form. Let me just double check. Yeah, that's just form. Okay, so that's just going to be a pass short. And before we actually get into what it's actually going to do here, I do want to implement our state machines. And I think I'm just going to implement my state machines in this parser file because we're only going to use the state machines inside these parsing functions, and we don't need to use it outside those. So I'm just going to declare those in here, and what I'm going to do is do them just before. So because we've actually declared our state machine objects in our handler file right here, what I want to do is actually import these into my parser file. So what I'm going to do is I'm going to say from, and because my handler file is inside the scpi file, what I'm going to say is scpi dot handlers import everything. And now it should know the sampling. If I type in sampling, it doesn't seem to recognize it. And Python's actually not the best language for importing and exporting stuff. Well, importing stuff. But let's just go with it and see if it works. And if it gives us any errors, then we'll deal with it afterwards. So what I'm going to do is say sampling. Come on. What am I doing? Sampling. Dot add state. So remember, in the state machine we had this function called add state. So the first thing we need to do is actually add a state before we actually get into anything else. So we need to add all the states that a particular state machine object can have. So that's what I'm going to do first. So I'm going to say add state, and the first thing is going to be run. So for our states, I can just come in here and look at the states that we arbitrarily declared. So it's either going to be run or it's going to be stop. So let's declare those. Run, and the handler for this is going to be my run transition, which is also something we imported when we imported everything. So I'm going to say run transition. It will be a lot more helpful if it actually recognized it, but for some reason it's not doing that. Add state, and I'm going to say stop, run transition. Okay, and the next thing we're going to do is look at the chan. So chan dot add state chan1, and the handler for that is going to be channel transition, and yeah, chan. So channel transition, and I'm just going to copy this and paste it 5 times, and here I'm going to say channel 2, channel 3, channel 4, and math channel. And the next thing is going to be mode dot add state, and for that it's going to be norm mode transition. Just copy that again, Control C. It's going to be 3 times, and make that max and raw. Finally, I'm going to say format dot add state, and that's going to be Word. Format transition. Copy that. paste, paste, and that's going to be byte and ASCII. Okay. So the next thing we need to do is set our default state. So if I go back into the state machine structure, you can see along with the add state we also have the set start, which is going to set the start state to whatever we assign, pass into this function, and we always need a start state, otherwise we're going to get an initialization error. So I'm going to give these state machine objects an initialization state. So let's say setting the start state, and for sampling it's going to be set start, and for that it's going to be run. Chan set start is going to be chan 1. For mode, set start is going to be norm, and for format set start is going to be byte. And I've also just realized that in the state machine structure, if you look at the run function, it actually takes in the protocol. So what I'm going to do for that is, because we haven't actually passed in the protocol into these functions, what I'm going to do is instead just create a protocol variable here, protocol, and I'm just going to assign it the value that's right. So we know that if it's in parse long, it has to be in protocol L, so I'm just going to create a variable called with the value of L. And same down here, protocol S. Okay, so in source, what do we need to do? So since we know that source is basically the channel, so it's the chan the chan state machine is gonna have to deal with the source. What we have to do in here is run the run function in the chan state machine. So if you look at the run function here, it's going to take in a cargo, and it's going to take in a protocol, and it's finally going to return an error if we do get an error state. So we do need to prepare for an error. So we need to catch that error in a variable, and we also need to provide the cargo and the protocol to this function. So I'm going to catch that error in a variable. So I'm going to say error equals chan. So we're going to use the chan state machine dot run, and for the cargo I'm going to pass in the parameter because that's what we're interested in. So I'm going to say parameter, and for the protocol, remember we created this variable here, so I'm just going to pass that in. Okay, so that looks like it. So if we do have an error, so if we do have an error, if error is not none, then I'm just going to print the error. Create some space here. So I'm just going to print the error, and remember the error is not actually going to stop our program or anything. All it's going to do is it's going to set the current state to the default state, and it's just going to return the error message saying resetting to default. So all we're going to do is just print the error for now. And if we don't get an error, what I'm going to do is print, let's say f chan dot get state is the current channel selected. So remember we had the get state function in the state machine, which basically returns the current state. So that's all we're doing there. We're just returning the current state and we're just printing that out. So that is the current channel selected. And we're gonna do something really similar in the rest of the waveform functions. So instead of pass here, what I'm gonna do is catch in the error if there is any. Equals mode. Let's just whoops. I just want to create some space here. And mode dot run, passing the parameter, comma protocol, and if there is an error, there's not none. Print the error. Else we're gonna print get state is the mode selected. And basically the format's going to be very similar, so I'm just going to copy and paste this. Control C, Control V. It would be quite helpful if it actually recognized these objects, but it's not, so I'm going to have to type everything out. It's kind of a pain for now, but hopefully it's going to fix itself. Format.getState is the format selected. Okay, so that seems to be it for now.